Last week, welcome back to my channel. My name is Joshua. I'm teaching calculus, and last week we discussed differential, differential and integral. We discussed that, and we defined what those are. Differential means a little bit of. Integral means some of. And then we tied it in, both of them together for a perfect definition of integral of the sum of a little bit of x, for example. So this time around, we're going to be talking about function, which is the next definition. I want you guys to understand these terms. Once you understand these terms, it is easier to understand calculus. So functions, we have two kinds of function: implicit and explicit functions. And functions is just a fancy way of saying things that are related, or how two variables are related. That's what we mean by function. So if you hear the word function, all it just means is relationship. So for example, we say x plus y is equal to 3, right? This x plus y is equal to 3 is telling you how x and y are related, and how they are related to what? To 3. So this is an equation, a simple equation, quadratic equation, but it's also a function. So it's a function because it's telling you how 3 is related to x and y, or how x and y is related to 3. So that's what a function is, the relationship between variables. But what do we mean by implicit function? Implicit function is when the variables are contained on one side, they are contained on one side, and then you have the other side of the equation. When I say one side, I'm talking about the side of the equal sign. So you have x plus y is in this side of the equation, right? They are contained on the same side. And then you have 3 on the other side of the equation by itself. That is an implicit variable. We can also write this variable in an explicit way. For example, if I write it as x is equal to 3 minus y. Now, this is an explicit variable, right? And explicit function, I mean. And the reason why I call it explicit function is because now x is on one side and y is on the other side. The relationship between x and y is still there, but now you've separated x so that one of them is now a dependent variable and the other one is now an independent variable. And of course, I'm talking about this right now, but we're going to get to that, what we mean by independent and dependent variable. But just now, when you're talking about explicit functions, now your x is now on its own side, and then you have the other variable, y, on the other side of the equation. They are no longer on the same side. That is why we call it the explicit variable. I can give you another example. So you have something like, for example, you have x squared plus 2x plus 3 is equal to 0, right? For example, this is an implicit function. Why is it an implicit function? Because the variable here, x, are on the same side, right? I can still write it as x plus 2x is equal to minus 3. This is still 2x, sorry. This is still an implicit function because the relationship of x, they are still contained. The relationship, the relationship is still contained on the same side. So this is still an implicit function. We can also write this as an explicit function, just like we did right here. So this is explicit right here because they are not on the same side. These two variables, y and x, are not on the same side. So that is the difference between implicit and explicit functions. Now we're going to go to dependent and independent variable. So the same thing, this right here is the dependent variable and this is the independent variable. The dependent variable is the variable that we're looking for. Is the one we're trying to find what the answer is, right? It is also the variable that its value depend on another variable, right? So let's take, for example, this same example of x plus y is equal to 3. And then we say x is equal to 3 minus y. So x is dependent, y is independent. Because depending on the value of y, we know what x is. So let's say if y is equal to minus 1, for example, so x is going to be equal to 3, it's going to equal to 3 minus y is minus 1. And if you solve for this, your x is not equal to 3. Minus times minus is plus, so plus 1. So your x is not equal to 4. So dependent variable is the variable that we're looking for, is the variable that is standing by itself and its value depends on the value of the other variable on the other side. That is dependent variable. The independent variable is the variable on this side of the equation where we sometimes know the value or where the value does not depend on the value of x. Take, for example, you have x squared plus x plus y minus 3 is equal to 8, for example. And then you rearrange this one to be x squared plus x is equal to 8. You take this to the other side plus 3, and this to the other side minus y. So you have x squared plus x is equal to 8 plus 3 is 11, 11 minus y. So you say which one is the dependent variable and which one is the independent variable. This is the dependent variable and this is the independent variable because depending on the value of y, we can find the value of x squared. Say, for example, if y is equal to, say we say y is 5, for example, right? Or let's say y is minus 5. Let's say y is minus 5. In that case, right, your x squared plus x is equal to 11 minus 5, right? So that x squared plus x is now equal to 11 plus 5, which is 16. So x squared plus x is equal to 16. So x squared plus x minus 16 is equal to 0. You can actually solve for x in this quiz, but that's not the point of this definition time. But now you can now find the value of x. So depending on what y is, will tell you what the value of x is. So x in that equation is the dependent variable and y is the independent variable. So that is the difference between dependent and independent variable. The next part we're going to discuss is differential coefficient. So we are done with this one. So now let's discuss differential coefficient. Let's define what that is. So if you recall, when we're talking about differential equation, we say you can have first order differential, second order differential, and so forth and so on. And then we said differential or to differentiate means a little bit of something, and we're looking for the small amount of a whole, right? So that's what a differential is. So differential coefficient is when we're looking for, this is just the ratio of a change in one variable to the relative ratio of a change in another variable. So when you see something like this is a differential coefficient. What does that mean? So for example, let's say we say y is equal to x squared, right? This is a simple equation, a very simple equation. Um, Differential coefficient is talking about the ratio between a little bit of x and a little bit of y divided by a little bit of x. Well, in this case, y is equal to x squared, right? So uh, here y becomes the dependent variable because that's what we're looking for, and x squared is the independent variable, right? In differential equation, let's add a little bit of x to x squared, right? So x squared plus a little bit of x, okay? But we know that because y is related to is related to x in this way, which is the function of x in this way. We know that if x increase, y is also going to increase. So y will also increase, right? Y is also going to increase. So x is equal to, so now the new x is now this, the new x. The original x was just x, but now we now have the new here. We add a little bit of x to it. So the new x is now s squared plus plus dx, right? So we can put that in that equation so that y has also changed to y plus dx to be instead of x squared we have um, x, sorry, it's going to be x plus dx squared, right? So that y is plus dy is equal to, if you expand this bracket, you have s squared plus 2x dx plus dx squared, right? Yeah, that's what you get if you expand it, okay? Um, but if you recall, we said earlier that um, we said that a second order equation, a second order differential is very, very small, so that this dx squared can really be, we can make it zero. Let me explain. Let's say that your x is 3600 seconds. That's your x. And then you took a little bit of that time. Let's say the time you took with dx, a little bit of time you took out of this 3600, which is 1 hour. Let's say you took 60 seconds. 60 seconds, okay? 60 seconds, which is 1 minute, is very small compared to 3600 seconds. As a matter of fact, if you want to check the smallest, 60 divided by 3600 seconds, right? So this give you this, you have 6 and 6 is 1, 6 and 360 is 60, right? This is equal to 0.00 something, right? So it's very, very small, second, it's very small. So this is the first order. The second order, which means you take a little bit of a little bit. So this is the first little bit. And you take, let's just say we take 1 second out of this one. So you take 1 second out of this 160. So compared to the overall, the dx squared is actually 1 over 3600 seconds, right? That is how small, how minute that second order differential is. As a matter of fact, if we make the calculation of this, it's going to be 0.0001 second. It's very, very small. So you can really say this one is, we can consider it for the purpose of this class for right now, we can consider this that is approaching, well, consider as zero. Let's just consider as zero. So if you do that, that this becomes zero, so that y plus dy is equal to x squared plus 2 plus 2x dx plus 0. So we'll call that one 0, right? Do you understand? We'll call it 0. So that way we simplify that. What we really want to get is we're trying to find out what our differential coefficient is. That is what we're aiming for, okay? So now we can continue what we're doing. We'll continue from the bottom, so that we know that from here, I'm just going to make a space here. We know that y plus dy is now equal to x squared plus 2x dx, right? That since that one, this one is 0. We also know that y is equal to x squared. So instead of putting y, we can put x squared in there so that x squared plus dy is equal to x squared plus 2x dx, right? So you have x squared and x squared. We're gonna put that to that side so that our dy is equal to x squared minus x squared plus 2x dx, right? So that dy is equal to x squared minus x squared is 0 plus 2x dx, right? Since we're looking for the ratio of dy to dx, let us divide both sides by dx, right? So that we have dy is equal to 0 plus 2x dx is 2x dx. So divide both sides by dx. Dx is going to cancel out dx. So that dy over dx is equal to 2x. This value right here is what we'll call the differential equation. So the differential equation, so to make it simple, so the differential dy dx of x squared is 2x, okay? That's what it is. So we've talked about differential, integral, function, dependent variable, an independent variable, and differential equation, and sorry, differential coefficient. This is what differential coefficient is. This is the last one. I went through the long way, but I'm going to show you the simple way again that we do differential or to differentiate a variable, right? So let's do this long way. You just see how we did it right here. Now, there's this common formula that we know. This is dy over dx, right? So if y is equal to x squared, right? The differential of y is, in this case, going to be dy over dx, okay, is equal to, this right here is going to be, there's a 1 here. 2 times 1 is 2x. 2 minus 1 is 1, okay? How do I do that? The formula is if you have x squared, okay, or xn, okay, if y is equal to xn, dy over dx, okay, is going to be equal to nx n minus 1, okay? Nx x n minus 1. So, for example, your n here is 2, right? So if you use that same formula, 2, you're gonna put your 2 right here because that's what our n is, and you return your x, and then 2 minus 1. So let's do it that way. So we have that. I'm going to draw a line here. So dy over dx is equal to, of this is going to be n, which is n here is 2, right? That'll be 2x. What is our n? N is 2 minus 1. So that'll be 2x. What is 2 minus 1? 1. So we don't write 1, just leave it at 2x, okay? So that is the simple question that you have. What if you have a constant? For example, say you have a constant in there. Example. So you have that y is equal to 3x squared plus 6, okay? You have a constant in there. We call this a constant because it's not a variable, it's a constant. We know what the value is, okay? It's not going to change. X is a variable, it might change. But we know that 6 cannot change because 6 is a constant. That's why we call it a constant. So we're going to use the same law that dy over d, or the same rule is what? It's going to be n x n minus 1, okay? So let's do it one by one. What is n? N is 2 here, right? N is 2. So dy over dx is going to be equal to 2. You have 3x, okay? And then you have 2 minus 1, okay? So that gives us 2 times 3x, that will be 6x. As a matter of fact, I'm not supposed to put in bracket. N minus 1 is, should be here. 2 minus 1 should be here. Bracket close. So that when you do that, that'll give you 6x. 6x, because this is a constant, when you differentiate a constant, you get 0. So that 2 dy over dx, when you differentiate this, give you 6x plus 0. So you have 6x. So that is how you differentiate that, okay? Let's do another example. Say you have, this example 2, say you have something like, I'm going to take this off. So you have something like 3x squared plus 2x plus 3. How do you differentiate this? So this one becomes dy over dx. The same thing. Don't forget the rule. We're going to use nx n minus 1, right? We're going to use that rule. That's what we're going to use right here. So let's do that real quick. So that our dy over dx, we're going to take them one by one. Let's take this one first. Our n is 2, so that will be 2, okay? That will be 3x, and then we have 2 minus 1, okay? Plus, here, our n here is 1. We don't usually write it 1, but our n is 1. So that will be 1 bracket x, okay? We have 1 minus 1, okay? And then this is a constant, so that will be 0. So that our dy and dx is now equal to, this is 6, this 2 minus 1 is 1, so 2 times 3 is 6, so that we have 6x. Plus, and then 1 minus 1 is 0, so we have 1 x0, right, plus 0, okay? What am I doing? This should be 2x, my bad, 2x. 2x, 1 minus 1, my bad. Because there's a 2 right here. So that'll be 1, 2, x raised by 0, okay? Plus 0, okay. So our dy over dx is equal to 6x plus x raised to power 0. Anything raised to power 0 is what? Is 1. So this becomes 1. This 2 times 1, okay? It's equal to plus 0. So that this one becomes 6x plus 2 times 1 is 2 times 2. That's 2. So that's 2 plus 0. So that our final answer for this equation is, for dy dx, 6x plus 2. So when you differentiate that, this is what, when you differentiate this equation, this is what you're going to get. So that your coefficient now, for your differential coefficient for this equation is 6x plus 2. So you can see that calculus is kind of very easy once you understand how things go. You can choose to do this the long way, which is the first example I showed you, but this is the short form. You can do this way. You're still going to arrive at the same answer. I hope you enjoyed this video. My next video, I'm planning to get a platform that will raise this board just a little bit so that it's high up. I don't like bending down. So that we can actually write up. Right now I'm bending down, squatting. I'm just trying to teach to help people to understand calculus. I'm going to try my best to finish calculus, and then I'm going to go to simple algebraic functions, algebraic equations, and things like that. But for right now, let's do calculus. If you have any question, put them in the comment section. I'll be eager to answer, to respond to any questions that you have, or reply to them. Thank you guys for watching. Catch you in the next video.